Welcome everyone to today's Treff. It's the first Treff in this year. I'm Patrick, hosting this to Treff today, and the presentation is done by Carl West.
All right, so welcome to Prospect Hill Forge, and I can show you a little bit of the place around me. I got forges over there, and I got a little bit more over this way behind me. There we go. Anyway, so there's a bunch of stuff. It's only really a few months ago I realized the big adjective that describes my approach to blacksmithing is shoestring. Cheap, nasty, get it done easy. All right, so I got a bunch of things that I want to talk about, and they are, a lot of them are hardy tools, so I'm going to come over here to the hardy, and all right, so hardy hole, lots of tools go in here. Classic first thing can be a cutting hardy. All right, so we got, this is a welded one. Now this, all right, so shoestring blacksmith doesn't necessarily even have a welder. This is nice. This is actually purchased from cheap, dirty blacksmith tools. I forget. And a long time ago, and it used to be a lot taller, it used to be a lot thicker, but students, they do things to things. So we fix them. Anyway, so a shank smashed down till it fits in nice. Woohoo, nice. But if you don't have a welder, what do? Well, one of the things you can do is take a piece of bed rail, which is a fairly high carbon steel. It's around 1070, and smoosh it in till it fits in your hardy hole. Make the shank long enough to stick out the bottom. So when it wedges, and it will, when it wedges, you can pick it back up again. The thing about these, don't bother trying to harden and temper it. It's a high carbon steel. You're using it on hot material. This is a hot cutter. It's thin. It's fast. It's not going to have a lot of time to get hot. It's thin. It will get hot faster than if it were thick. But and if you just normalize it, this one's gotten blunted. The student was less accurate than we'd hoped. But I can just put it down here on the edge, tilt the hammer a little bit, and put an edge back on it. Boom, boom, boom. Without heat. Fast, quick, cutting hardy. Once you've got one of these, you could go so far as to take a piece of leaf spring and use this cutter to make these cuts, cut in from the sides, gather this stuff up into a shank, which is way heftier than absolutely necessary. And in this particular case, I've made it a butcher. Can we see that one there? There we go. So it's the one-sided kind of cutter, and it doesn't fit this anvil. It goes in a different anvil. Yeah, I've got a couple of different sizes in the shop. Anyway, that, right, this is another one. This was just a straight up tapered cut. And it's narrow, it's fast, and there was a whole bunch of smashy to get this down to fit, again, not in this anvil, one of the others. So cutting hardy, quick, easy, cutting hardy. People are throwing out bed rail on a fairly constant basis. I just picked some up yesterday. It was next to a dumpster, had the little wheel things on it, and it's usually brown or black. And Paul Wahlberg has a knife made out of this stuff I made for him, and he's very, very, very happy with it. He tells people it came from a brothel, but he's wrong. Anyway, other very simple tool to make, and that it gets used in the vise. So we're going to come over here to the vise, and it's a bending tool. Just stand it up, clamp it in. You can put your piece of work in there and bend it. These grooves are so that you can, there's this tool, you can put a piece in and hold it on the diagonal and get a lovely diagonal bend. This kind of thing going on. Easy to do if you've got some grooves here to help hold it on the diagonal. Right, these grooves were done on a hardy to start, and then on the corner of the anvil, so that the shape of the hole, can I do this with my hands? Yes, I can, is kind of like this, so that it's not dinging the very edge of the material, nor is it leaving corner marks in the surface of the material a little bit away from the edge. Some tools are very confusing to use. I've got, well, actually, okay, so I've got this numb spot on my finger from 2013 when this handle fell, all 2.5 pounds of it fell bahwonk onto my finger and made some pate in here. So what I've got now is a spring on here that keeps the handle from sliding quickly anyway. And when it's nice and tight, I can actually use the vise as an adjustable slot tool. I can have it that wide, I can have it that wide, or that wide, or that wide. And for the most part, make a liar out of me, the handle doesn't slide and change it for me. On some vices, unless the spring is really, really strong, you hold it like this and the handle slides through and it goes whoop, like this. And now you don't have the size you wanted. So that's what this is about. It lets me have it here or here, and it cuts down on how hard it slams down. And I haven't had a problem since. That was what, 12 years ago, and I'm slowly getting feeling back in my finger. So there's that. Also, sometimes if I'm clamping something hard, let's see, I need something that's going to show this. All right, so I need to clamp really, really hard on this, and that angle's pretty good. All right, how about I want to clamp really hard on this? Okay, yeah, this gets me. My handle's just about vertical. I cannot drop my weight on that and get the vise really tight. You can address this in a couple of different ways. One is to add something into the vise, a jaw protector kind of thing. Another way of dealing is something that goes, a space that fits in here and is the right thickness to shift your tightening angle. So now putting a 1/2 inch pair of tongs in here. Aha, and now much more level. I'm going to give you a better view of it. So now I can tighten this for real. And now that's not going anywhere, and I can upset on it or whatever I have to do. It's not going away. And that's done by adding a little spacer in here. These bends here help keep, oh, come on, you. Oh, there it is. Keeps this from swinging up while you're working the handle. Otherwise, it will happily pivot up and stab you in the fingers while you're trying to do something good. So that's a vise trick. That's another vise trick. And as Frank Turley says, no tricks. Vise technique, vise tool. And I have them hanging next to the vise. So that's those things. While we're at the vise, classic twisting tool, right? Everybody has seen this. I'm gonna just pretend with this here. Okay, so say I wanted to twist this, I would use the 3/8 side and run it on and twist it up. Get a long shot on this. There we go. My hands are not directly across from each other on this twist. And if I'm doing 1/2 inch, which is the other size here, I'm still off center. It makes it a little harder to keep your twist really straight. What do? Well, what I've done with it is breaking out of that two-dimensional way of thinking, and now when my twisted piece is in here, my work is in there, my hands are the same distance to either side of it. I'm more centered and more centered. Both sides, I got them. It'll happen. And this works, it's pretty good. You want to play fussy though? I've given it a bend here that puts me right on line and right on line in both directions. You can do it. It's just a tiny bit more work. What the heck? You got the tool forever, or at least until you have to fix it. So, twisting wrench. And then there's the adjustable twisting wrench. Now, start with something like this. Most folk weld them on here. Now, this calls for a welder, but that leaves you off center. Why not weld it on here? It's just as strong. Weld it on there, and now my hands are pretty much opposite each other relative to the piece, and I get to have straighter twists more easily. Just, if you're going to do it, take the moment, line it up, do the thing. Classic spring fuller. Spring load, like this. Eventually, especially when you have students, eventually they break. All right, there we go. This is going to go. It's going to fail. So what have I done? I've said, enough of that. Give me a hinge. That's not going to break as easy. And what I've done and the shank doesn't have to be, am I locked up? There we go. The shank does not have to be a whole square. You just got to catch the corners. And it's really nice if you can manage to catch in 3 places. In this case, on the high side and down low, and then somewhere in the middle. And that's what this is doing here. Now I want to put this into the anvil. That is bearing now down on the inside of the hole. This is pretty damn stable, and I can choose what part is actually touching because it's picked up some curve. And ta-da, my tool is pretty happy. This one, because of its curve, and it was made to fit this anvil. It's a happiness. Again, make the shank long enough so that you can drive it out from underneath. Happiness. And you can, spring this back out if it gets loose. It's like making tongs, just don't make the tongs. Even better, especially in a situation like mine where things move around from one anvil to another and they don't necessarily fit the same. I've given it a hinge here, and that lets me push her down in and make it fit wherever, and it's going to fit whatever anvil I put it in. So there's that. When I'm using one of these, because I know there's slop available, if I stand here, then I can see what's going on. If you stand to the side, you're not going to see as well where you're really going to hit. So like this, and strike directly on top of the piece. And the other thing about tools like this, be they hinged or spring or whatever, super quench. Mild steel tools. These are all mild steel, and I've super quenched them, and they stand up pretty well. I'm a big fan of super quench. It works, it works. What else I got in here? Right. So this one, this isn't quite a lone smith tool. It's a top and bottom swedge with the shank pivoting, so it'll fit whichever anvil. And in fact, this will fit almost any anvil because the shank is what, 3/4 and smaller than almost all my hardy holes. So I need to go get my box of which are pieces Well, actually, there's one or two in here that are actual angle iron. Yeah. So, piece of angle iron, split a little bit, bend it out, fits in the other hardy holes in the room, but not this one. But also just a piece of like 16 gauge. I punched the hole, I cut to it, bent it in the vise, bent it in the vise. That helps. That helps more. That holds this fairly still. Let's see, can I get one more? And one more, do I get it? Yes, and that keeps this stable enough for being able to work with it. Another trick on this one, technique, a little specialty. This is forged, but being able to open it up, you come in with your hot metal, I'm trying to get it in there, trying to get it in there, come on there. I'm trying to get in, it won't get in, put it down. Okay, this was forged, right there, using a tool, just a board with the different size rods in it for the different size holes, and with a flatter and an apprentice. I needed someone with a sledgehammer, and so we got the whole shebang hot, brought it out, dropped it in, put this in place, put the flatter on top, and ka-whanga, whanga, 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 and that's the technical term. And we got the grooves, and they have that little bit of suck that you get, and that's nice for a top and bottom swedge anyway. Adding these tusks helps keep it aligned. And let me get out of here. There we go. And detail of how this is going. How's our light? There we go. So this piece was sawn, so it's in the middle, heated, bent out, and then flipped up, then drilled. If you have a drill press, awesome, it helps a lot. This hole was drilled, but these pieces are riveted on, and they help keep the alignment side to side. There's enough slop in it. I can set it up. Sometimes I can set it up so that it stays up. I bring the work to it, tap it, closes up, down to size, whatever your sizes are. I hope that makes sense. Top and bottom swedge, twisting tools, stuff. Well, what the heck? Monkey tool, very simple. It got to have a drill press. Well, no, all right, I guess you could hand drill it, but it's a deep hole, deeper than any tenon that you're ever going to make. It really sucks when your tenon bottoms out in here while you're trying to upset the shoulder, and then it's riveted into the tool, and then you got to let everything cool down before you can get it out. And this has been super quenched, which is taking it up to a light orange, a little bit lighter than orange soda, if that helps you. And it makes marvelous noises when you quench it. So there's that. A useful tool for prying stuff. I use them. Oh, stop bumping the camera. Jeez. Okay. It's basically a screwdriver sort of thing. It's a pry tool on this end and a round pry tool on this end. Really nice for helping make corkscrews. And tongs to hold tools, and on the other end, a catch to keep it latched. This is a piece of garage door coil spring, so I didn't have to mess with it much. I just sprung it so it's round. Happiness. Okay. Also for holding chisels, punches, whatever. In here, really, fight with me. There we go. So it's in, and then on the other end, tightening. And in fact, this one has been set up. This end here fits the hardy hole. I don't even have to have a wrench or the vise or whatever. And there's everybody. So with that in place, and I can just spin it down. It's a threaded rod up inside. So clamps tool, quick to replace. Automotive coil spring tools. Shoestring blacksmithing. That's what we're doing here. That's what I'm doing here. Anyway, I learned that one from Dave Anderson out of Tonawanda, New York. I'm done and happy to answer questions.
Yeah,
one more. This tool right here, just a piece of 3/8, but I ground it off at a slant. It's now a butcher that you can hold down to the anvil with the chain hold down, and you can work this way, turn it around, work the other way. You could also use it this way, depending on what you want. So, and these were made for Beth's class that she taught here. So, all right, now I'm done.
Okay, fantastic. Yeah, Carl, thank you so much. So,
Okay.
Mariano Garabato, the grooves in the bending tool, why not put it on the bottom? Or is it the same, or why are they on the top?
If I put it at the bottom, a student is going to try to bend cold above and break it. They've done so even at this point. That's why. Yeah, and it's good and solid down here. Yeah. Why put a weak spot right there? So, yeah. Okay.
Yeah, looks like the question
I think
was
I've answered that one.
Yeah, and then the next question is, what material did you use for the fuller tool?
The fullers, it's all mild steel.
Yeah.
Everything I've shown you, except for the actual chisels that I held in the holder, it's all mild. And them and even these, I super quench them because I can, and it certainly doesn't hurt. I believe it helps.
Okay. Yeah, which leads to the next question. Do you use salt on the water for super quench? And then there has been a couple of posts, and Beth has revealed the recipe, and it sounds, maybe I just read it out loud. Super quench, 5 gallons water, 5 pounds salt, 1 medium bottle of Dawn dish washing liquid or fairy, large bottle of dishwasher anti-spotting liquid.
Yep. Yeah. The tricky part is trying to get the equivalents in different countries. Dawn is a little unique in being a really good degreaser. And they have a patent on that. And you don't want just regular dishwashing soap. You want this particular degreaser. And I think when I looked it up in the UK, it was fairy, I think. But you want that very strongly degreasing dishwashing liquid. And then you need a surfactant, a wetting agent, and the dishwasher anti-spotting liquid. So this is something you put in your dishwasher in addition to the detergent that makes it so that in rinsing it runs off very nicely and you don't get little spots.
Yeah.
That you it's an 8-ounce bottle of that helps with the quenching. And as Carl said, it makes noise. If you haven't used Super Quench, you use it at the same temperature that you do any other kind of hardening quench. Maybe, as he said, a little hotter. Yep.
A little hotter.
And you know it worked if it screams when you put it in and agitate it. It sounds like it's screaming. And what's really fun is those are tiny sonic booms from the crystals warping. Which is awesome. Yeah. And it hardens mild steel to Rockwell 50s without adding any carbon. It comes from the tension of the crystals being slightly out of square. Very cool stuff.
Yeah.
You can't afford not to. It's so cheap. Yeah.
Oh, yeah. Yeah. And it lasts a long time. My bucket, this bucket's like 4 or 5, no, holy crap. I made it at least a couple of years before pandemic. So yeah, it's 6 or 7 years old now, and still works great. You can actually make a decent knife out of a railroad spike with this stuff. Not a great knife, but a decent knife.
Wow.
Just saying. Yeah.
Okay. Yeah, no, then there is a bit more, like here is also for mild steel, like temperature for quenching, asked Jim T. I think we covered this. I just read what is written here. Mariano says around 1,000 degrees Celsius, though. Whatever this is in
Celsius.
Fahrenheit.
Yeah,
But,
I got nothing. I'm an American. It's all Fahrenheit.
Light orange in lighting conditions you can recreate regularly. Outdoors, it's a bit funnier.
Yeah.
Okay.
There is no tempering needed. Somebody asked about tempering.
Yeah.
When you super quench, it is both hard and tough. It's not brittle. I don't do blades because I think they tend to warp, but it's great for top tools and bottom tools, and thin, mild steel springs that are too thin, and so they won't spring open again. You super quench it. Spring.
Yep.
Super
I did the poor man's IZOD test. You know, I took a piece of mild. We usually do this with spring just to find out how to work with it. Put in a bunch of notches, heat one end up to not quite burn in, leave the other end dark, quench it, and then we'll stick it in the vise. And at the hottest notch, you hit it, and the hammer tends to just pass right through as it's so brittle and it breaks off, and you got massive grain and and you do the next one, and you've documented all this on the way, and you end up with kind of what you want to do with that particular steel, whatever that is. I did it with some mild steel in the super quench. First move, it was almost burnt, and I tried to, I super quenched it, I put it in the vise, and I hit it with the hammer, and the hammer bounced off. So I hit it harder with the hammer, and the hammer bounced off. And I swapped out to the Macho hammer. All right, that's how big it is. It's 8 pounds. It's all, it's not quite the size of my head, but it's 8 pounds. And I swung it as hard as I could do so accurately without dinging the vise, and it still bounced off. And at the same time, I could just barely touch it with a file. I'm a big fan of this stuff.
Another question before. Could you talk about your chain stay, please?
Okay, my chain was a little bit long, so it's got a knot in it, and I didn't bother adjusting it that way. It was coming down too far on the other side, you'll see. So it's in with a lag screw here, coming up and over the anvil, and then back down to a sash weight. Cast iron piece. This is about 8 pounds, and it works very nicely for holding stuff down. You know, if I wanted to work on it with this tool, what am I going to, I'm going to have a thing. Fine. I'm going to work on this hammer handle somehow, but it holds it down enough so it's not leaving, it's not bouncing off, it's not flying across the room. And if I keep watching what I'm doing, I can do what I want to get done. The thing about the chain, you want welded chain, and I recommend curb chain, which has this with the twisted links, so it doesn't leave you with gaps that don't actually hold. I mean, this is dancing on the edge, but it's enough to keep it from flying away. Bicycle chain, motorcycle chain, that also works. It's not as flexible this way. It doesn't do that, but it will get you most of what you want. And you can put it over here. I have used it in the past to help hold a tool in place because it wasn't fitting. That was before I made my party hole adjusters. But useful. It usually lives right here, which keeps the weight off the floor. I get a lot of people say, "Oh, get that out of the way." And now it's an ankle breaker because you step on that and you're going to twist something. But you can also put it out of the way. On the London pattern, you got this place to put it, you got this place to put it. And And if it's all in the way, you can just put it over there. Get it out of the way. Smith up. Don't put up with crap.
I guess also helps to prevent the sound of the anvil.
Oh, sound of anvil? No,
Yeah.
I do that. Let's see. With. Can we see it? Let me see it. There's the underside of my anvil. Speaker magnet.
Okay.
Yeah. Works great. And it's not in the way, you know, if you wrap a chain around the waist, it's in the way of stuff. This is typically not in the way. And if it is, move it. Easy to do. Making sense?
Yeah.
Yeah.
The next question by Martin's iPad. Emery was already answered. Do you have any fly press trickery tools?
I have a fly press. You may have noticed it in the background. And I have not built any vocabulary for it. It mostly just sits there. I used it several years ago. This is a teaching situation here, so I need to be able to work it into a class. And I've only got the one, and I'll have 4 or even 8 students. Well, not for that. I would have 4 students. So I'm still trying to figure out how to do that. So no, nothing really good for a fly press. Sorry about that. I wish.
No, yeah.
Same for the hydraulic press, same for the treadle hammer, same for the power hammer. They're not something I use in class, so they're not part of my vocabulary. So I don't have any good tricks for them.
Yeah.
Or techniques.
Well, next question from John Hayden. Can you talk about the layout of your tool tables at each station? Everything in its place.
That is a whole other 20-minute presentation. Thanks, John, but no. I mean, well, all right. So I'm just not going there.
It's the rabbit hole.
It's the smallest bench, and I've got stuff on all 4 sides of it for different things. I got my blacksmith vise and the machinist vise, and I got tools, and I got tongs, and I got all right. So here's one actually. Where'd it go? This tool.
It's very close to organized.
Very close.
This far from organized.
Yeah, but check this one. So we got my brush, using it for brushing stuff off while doing a forge weld. There's a little hook on the back, so I can hang it up. Okay. So, and I've got it set so it's just a reach right here to use it. And on the other end, the classic flux spoon. All right. Because one day I was holding the long flux spoon and the brush in the same hand, and I brushed and dipped and went, duh, put them together, and it's been this way since. This is the way to go. I think. Do as you please. All right. But so,
blacksmithing.
All right, I think I'm done with the spotlight for the moment. Other questions?
I'm trying to think what else in your shop I've seen that was really cool and clever.
Oh,
there's a lot of cool and clever in that shop.
Just keep looking.
What do we got?
Right? Just keep looking.
It's the rabbit hole.
It is that shop is a rabbit hole.
Yeah.
It's very simple.
Rabbit warren.
The more you see.
Yeah, rabbit warren.
Yeah.
You know what you could talk about, Carl, which is interesting, is your forge exhaust fan and how you've got that set up.
Here's a forge. So, with a hood, bent piece of sheet metal.
It's got that blast gate.
A little bit of wiggly material so that we could get it to line up. And then our engineer spec'd out. He insisted that it not be galvanized because he was afraid of galvanized, the zinc getting on, getting hot and so forth. This thing never gets over like 130 degrees at the hottest spot. But anyway, so it goes all the way back. It takes in the vents from all 4 forges. And then there's basically a restaurant style ventilator on the back of the building. sucking on that pipe and taking our smoke away, blowing it out to the bike path. So, and there was an ant. There was a sign out back saying, "This is a blacksmithing school. Smoke is normal. Please do not bother the fire department. If you see flames, that's another thing. Make the call."
Yeah. So
makes sense.
Carl also has a blast gate or a gate.
Oh, yeah.
On each forge. So
yeah, each one, and a VFD to. Oh, come on, you! I'm in my own way. Sorry about the motion. Yeah, I got a gate opening and closing, so I can have just one forge going, and then I can also have I can turn the ventilator down. Especially nice in the winter when sucking heated air out of here is just a sadness, because I got to suck cold air in to make up for it. So,
can you comment on the? This is John again. On the different, blasts going into the bottom of each forge. I think each one of your station is different.
Well, all right. So
yeah, there's a lot of good air sources.
Part of the deal here is that I don't want students going away saying, "I know exactly what kind of forge I have to have, because that's how blacksmithing is done, and it isn't done any other way, and I have to have the perfect forge." That's bullshit. Okay. So my first forge, forge number one, all right. Down there, you can just see the hood of it. There is a Buffalo 660 or 0660. First hit their catalog in 1916, best I can tell. Can we zoom in a little bit? Yeah. Anyway, that one. This one, forge number two, was built in this room. It has, for its fire pot, a cut-off helium can, like that one. Cut it about 4 inches tall, and using pipe fittings for the tweer with a slot in the top of a pipe cap. That works pretty well. Forge 3 has a piece of sheet metal across it with all my stuff on it. But in here, it has a pipe tweer that lets me have a fire as long as 2 feet and fairly narrow. The idea being able to temper harden and temper a chef's knife sort of thing. And then Forge 4 was my first week's pay as a blacksmith. It's a champion hand crank, and doesn't have a fire pot. I've heard people say you cannot forge weld in a rivet forge. That's bullshit. I have won competitions welding in this very forge. So it can be done. If you can burn metal in it, you can weld in it. So,
bonus question. With the hand crank, the timekeeper pendulum you have.
Okay, yeah. I'm pleased with this trick. I'm in my own way. Here we go. So especially with students, there's a how fast do you crank it question. And what I've done is given them a timing tool. So if you can match the pendulum, can you see it in the video?
Yes.
Yeah.
I'm matching it for left and right as best I can, and that gets me about the right speed. And Forge 1 has a hand crank also. Its pendulum is a different length because it's a different blower.
Wow.
So
hey,
that was I felt real clever when I came up with that one.
Lots of good information. Thank you, Carl. This has been this has been a fantastic presentation. In case you want to support this project, there are 2 fantastic ways how you can do it. Number 1, you have something to teach, and you feel like you can also give a Treff presentation. We have had all kinds of skill levels present here, all kinds of different topics. So feel free to contact me, usually it's me if you go on the website and write an email there, or contact Mariano or contact Paul Voss. Anyway, no topic too small, and if you think this is a good way you can contribute, please do so. The other way, if you don't think this is an option because you're in a weird time zone or whatever, we have started to gather donations via Ko-fi. This is a service which takes care of the payment and handling of the fees wherever, like handling of the payment wherever people come from. Thank you everyone for coming to today's Treff